everybody. Thanks for coming to the Gun Tea this Friday. We'll be learning about the Vermont Climate Assessment. There are these nice little cards that I saw out there on the table. If you want more info, you can visit the website on the back. Our main presenter today is Gillian Galford. She's a research assistant professor in Rubenstein School of Environment and Natural Resources, and also from here at the Gund Institute for Ecological Economics. She's an earth system scientist interested in land cover and land use change, and she led the Vermont Climate Assistant Atelier class, and there are other co-authors from UVM who are here today. We have Elizabeth Balchik, Elena Thompson, Julie Nash, Ann Hugenboom, Kristen Underwood, Daniel Baker.
No.
And anybody else? Another Daniel Baker.
Where's the Danny Baker? Yeah, the tracking you, the tracking me. Damn, I was on the climate assessment.
The doppelgangers meet in person. I don't know which one people know. So with that, we'll get started with the presentation. If you want any tea, there's hot water and tea out in the hallway. So, thanks, Julian.
Sure. There we go. So it's an honor for us to be here at the Gun Tea. We, as a group of authors, have had lots of opportunities to present our work to a broader community. So it's nice to have a little bit of an academic focus today, and to also look at the science, but also the process behind the Vermont Climate Assessment. You can read the full report. It's available online at vtclimate.org. And we try to stay active in the climate change community using Twitter and Facebook to relay messages about climate change issues relevant to Vermont, the nation, and the globe. So you can find frequent information there if you're kind of a climate nerd or you like learning more. Definitely check out that. So today's format, I was the lead author of the study, and many of the authors are sitting here with us today. A few who couldn't be here, we will be filling in and presenting their material. So as I said, we'll go through some of the science behind the report, as well as the motivation and the format, how you get this done as part of a graduate course. So to start with, this is kind of a global shot, make sure we're all on the same page. We have seen rising CO2 concentrations in the atmosphere, particularly since the 1960s, and the science is definitely in and conclusive on the fact that increases in anthropogenic sources of CO2 are forcing increases in the Earth's temperature, which you can see shown globally in this figure. This past year, we're blessed with a national climate assessment looking at regional impacts of climate change across the United States. And in these figures, what you can see, they're fairly small, but they're showing the change in degrees Fahrenheit from the average temperature. So starting at the beginning of the 1900s and moving forward decade by decade. So you can see for most regions in our country, we're heading in a warming direction. The National Climate Assessment has also provided us with models of future emissions and what that would mean on the ground in terms of temperature and warming. And if you zoom into Vermont, we seem to fall into only two categories, which is about 8 to 9 degrees of warming. So some good detailed information on the national level, but it really has some local limitations. So those are fairly coarse representations of how climate change will affect Vermont. The report doesn't provide a whole lot of examples of impacts specific to northern forests as well as northern livelihoods. So for example, this is a picture taken after Tropical Storm Irene. We had many roads looking like this all over Vermont, a very iconic photo though to typify Tropical Storm Irene. So these large storm events that have extensive damage on our infrastructure. These national and global scale projections of climate change really don't tell us much about where and when these might happen, how frequently they might happen, and how we can better prepare for these. Okay, so when we're looking at the national level, we get very coarse information that's hard to translate to direct action in Vermont. And that was a large part of our motivation for doing the Vermont Climate Assessment. After going through the National Climate Assessment, our course of graduate students decided that they had a moral obligation to provide a similar report on the scale of Vermont. So looking sector by sector at the impacts of climate change and how they will impact us as Vermonters. So, oops, I'm going the wrong way. This is an example of some of the information we collected. So looking from 1960 to the present, these are the changes in blue in precipitation and changes in red in temperature at different stations across Vermont. So we've already seen huge increases in precipitation in Mount Mansfield. A lot of that's falling in the winter time, which means really good ski years. When it's a good year, it's a really good year. We also see increases in Burlington. So this is about a 10% increase in Burlington since the 1960s and over 20% increase at Mount Mansfield. So we know that climate change is already happening in Vermont. And in fact, if we look across the country, we see some areas, for example, the Northeast is showing a wetting trend. We're getting more and more, a larger percent change, so a positive change in precipitation, whereas areas like Hawaii are getting drier. There are more seats in here, so people should feel free to come on in. And if we focus on the Northeast, if you've lived in New England for the last 30 years or so, you can attest to the fact that it is indeed getting wetter. So the point here is that we have seen temperature changes. So these are 8 stations across Vermont showing the trends in temperature going back to the 1800s in some stations. And if we focus on the 1960s to the present, this section here, that's when most of the anthropogenic forcing from greenhouse gases comes into play. So we definitely see a clear trend across Vermont, and that helps us communicate the fact that climate change is already happening. It's already here, and we can expect future climate change to continue along these trajectories with some sort of variation, probably in the upwards direction given our current rates of greenhouse gas emissions. So we were very interested in looking at the impacts that these changes are already having in Vermont. So for example, we can look at the date of the last freeze and the first freeze, and what you'll see is that our winter season is getting shorter as these two dates converge. You can also think of the opposite, which means that our growing season is getting longer over time.
Joanne,
Mm-hmm.
do you want us to hold questions, or do you want us to interrupt the questions while you're going through this?
We'll have plenty of time at the end, so thanks for asking them. I want to get through all their topics too. So here's an example of what our station-specific data looks like. And if we take this precipitation and we start thinking about how this precipitation falls, so not just the fact that we're getting more precipitation, but for example, here are the number of storm events per year where we're receiving more than 1 inch of rainfall in Burlington. So fairly clear trend. We're now getting 8 to 10 of these storms a year, whereas particularly in the 1960s, we were down in the range of about 4 or so. So there's a lot of data already in Vermont suggesting that climate change is already happening. We're already experiencing its effects. And there's a lot of data sets that we as scientists typically don't think about. So this is Ray Allen. If you've ever been to Allen Home Farm in South Hero, they have a very nice petting zoo, great apple picking, all these sorts of things. Ray Allen has been running this farm since 1968, at which point he became a co-op observer for the National Weather Service. So this means he actually has a weather station on his property, and he records every day the min and max temperature as well as a number of other climate variables. He has a workbook for the year, and he tears the page out at the end of the month and mails it to the National Weather Service, and they enter the data for him. He hasn't gone computerized yet. He gets a carbon copy, he keeps that book, and what Ray has done is he's recorded for his Macintoshes the onset of bloom. So this is actually the date of full bloom. So he records on his copy of his climate records his own phenological logs. So what this means is that at this particular site, we have a detailed record of both temperature and of a real event, in this case phenology. Okay, and at first glance you might say, wow, if the apples bloom earlier, you may have a longer growing season, you might get more fruit, you might get bigger fruit, but there's a number of problems that come with this change in bloom date for farmers. For example, if they're blooming at a period when there's a lot of rainfall, a bloom is basically an open sore on the tree that allows for fungal and other types of pathogen infections to actually enter the tree. It can cause scab, which creates an ugly apple instead of a pretty apple. If you get too many blooms, it can actually produce smaller fruit, and the farmers have to go and take some of the fruit off the tree to try and encourage the others to get larger. And some of the ways that they cope with this earlier bloom date, and particularly the risk of pathogens, is typically by spraying more to try and combat those pathogens. They don't like spraying, and they definitely don't like spraying when it's raining. It's a really good way to get tractors and stuff stuck in the mud. And obviously, the more work they have to do to take care of these apples, the less profits they get in the long term. But from the climate data at Allen Home Farm, we see a change in temperature of about 8 degrees since the 1970s, and we see a retreat or an earlier bloom date by about 7 days over that same period. Another very compelling story that you may have heard is Joe's Pond Ice Out Contest. So Joe's Pond Association raises money for its 4th of July fireworks every year by holding a contest where you can submit 10 entries for $10 and guess what day the cinder block will plunge through the ice and into the pond. So it's a measurement of ice out, the day the ice melts on Joe's Pond. Winner gets half, which these days is about $4,000 to $5,000. So a very sizable prize. People are winning from Ohio and Minnesota. It's become a national event, as well as a local event. But what's really powerful about this story is that it's both a charming story, but it's also a great science experiment. So the cinder block is tied by a rope to a simple clock, and when the block plunges through the ice, it pulls on the rope and unplugs the clock, recording the precise time at which the ice went out. So this contest is usually won by minutes, not by days. Okay, so people win if there's an odd ice out at 10 p.m., which I think happened 2 years ago. We had a warm overnight temperatures in the spring, and the ice out happened in the middle of the night, which was a little unusual. They have upgraded. They now have a weatherproof clock. That's a little bit more reliable, but that is the only change in this citizen science methodology since they started in 1983. So if we look at their data, we also see a very clear trend that ice out is indeed coming much earlier. There's a lot of variation depending on the weather during that particular year, but a very clear trend in the upward movement of that ice out date. Now, West Danville's in a little bit more mountainous region of Vermont, but we're still seeing this date has come forward about 5 or 6 days since 1983 when they started their measurement. So you could use this plot and do some, I don't know, probability distribution functions and try and game the system and see if you can win this year. But the point with these stories from Allen Home Farm and Joe's Ice Out is that there's a lot of data sitting out there that really resonates with people. So it tells us the climate story as well, or maybe even better, than looking at the National Weather Service station. So Joe's Pond, a lot of people read about in the news. It's a very entertaining, interesting story. It's a great example of how we can communicate about climate change in the environment using stories that people can relate to, that are whimsical, and that will probably stick in your mind. You'll probably remember about Joe's Ice Out Pond and the fact that we're seeing ice out come earlier. Likewise with Allen Home, almost everybody in this room, I would assume, has been apple picking somewhere in Vermont, has enjoyed one of UVM's own apples. And these are the types of studies that I think we have a lot of potential to expand across Vermont, and are some of the opportunities that I'd be looking for in the future to continue working with citizen science and communication around climate change. These stories also resonate very well with Vermonters, most people who grew up in Vermont or who have lived in Vermont for 20 or 30 years. will tell you that they have seen things change out their back window, whether it's the pond in their neighborhood, or the blooming of the trees, or the timing of the color on the trees, that they've seen things change. So when you provide them with evidence that says, in fact, we've measured this and things are changing, they feel very affirmed. So it's a message that Vermonters buy into because they've witnessed the impacts of changing climate in their own backyards. There are some sources of data that we need to be very leery about. So this is an example from Lake Champlain. So if you go from our small little Joe's Pond to thinking about icing over of the entire Lake Champlain, we've been making measurements back to 1816. And if you look at this at first glance, it looks like we're having much less ice out. So the dots that fall on the 0 line mean there was absolutely no ice, or there wasn't full closure of ice on the lake, is what I should say. And this is coming how many days after January 1st this event occurred. So you might be able to say that it's icing up a little bit later, maybe it's like icing over less. But here's the caveat. In 1816, these measurements were made, and the measurement was really whether Burlington Bay iced over, if they could get boats in and out of Burlington Bay. And if they couldn't, the lake was considered iced over. Does that mean the whole lake was actually iced over? Who knows, right? And so there were a number of different methods of observing this, moving from the bay, from actually dockside down by Echo to Burlington Bay to further out. In the 1930s and 40s, the methodology changed, and private pilots who are flying in and out of Burlington Airport would call in as they flew over the lake and report whether they thought it was iced over or not. So they had a good aerial survey, but again, a slightly subjective measurement. Now, in the 2000s, we've gone to monitoring it by satellite, so very repeatable, very unbiased observation. But as you can see, it's very rare that we actually see the ice completely over Lake Champlain. But it's impossible to say with this data record if we're seeing less ice over, because the measurements and results are just so uncomparable. However, you will see graphs like this presented as though this is one continuous measurement made over time. So believe the data, but also question the data about where it's coming in. Is it a repeatable measurement that makes sense time in and time out? So for the rest of today, that's kind of a primer to how climate is changing. We're going to talk more about our findings, but also about the process. So this process was started when I came to UVM about 3 years ago as an idea to do a state-relevant climate assessment modeled after the National Climate Assessment. The Vermont Climate Assessment is in the National Climate Assessment Network of Partners, NACANET, and was supported by some of the lead scientists on that report conceptually. The state climatologist reviewed the initial proposal and was very supportive. We, at the end, will show a lot of acknowledgments, but the National Weather Service also came on board and helped us with this a lot. We initially started the project thinking each student might do their own independent graduate project related to their thesis and related to climate change. And in fact, when we sat down as a class, the class decided that they wanted to abandon the idea of individual projects and really work on a cohesive report that would be meaningful to Vermonters. And from there, they went out to engage with stakeholders through a process I'll let Danny describe.
Yeah. So my name is Danny. I was a service learning teaching assistant for this class last fall, which means I was in charge of communications with our community partners. So that's both data sources and beneficiaries, people who would be interested in the report. I also wrote the health chapter and filled in for a few other writing pieces in the document. So what is a service learning course? These are courses that use the course material to apply it to a real world problem, teaming up with a community partner to further students' understanding while simultaneously providing a service for the community. So it's mutually beneficial. It strengthens students' understanding of course material and what they're involved with while benefiting the community. And in this case, the benefit was extremely large. Typically, service learning courses, I've taken quite a few as an undergrad. Their benefit to the students is variable and their benefits to community partners is even more so. Sometimes they're successful, sometimes the service is completely absent. In this case, there were many, many community partners and many, many beneficiaries. I don't know if anyone has had a chance to read the report, but it's been widely disseminated and it's already been used in quite a few places. So yeah, the community partners included scientists, businesses, municipal governments, nonprofits, and as Gillian showed us, citizen scientists around the state. So another aspect of the course that was very important to its success was team-based learning. This course is a near perfect example of team-based learning. Semester-long group projects is that's what it was. Everyone had a diverse skill set and background, so we had quite a few different graduate degrees, and people were really able to focus on a specific topic and chapter and apply their own personal expertise. Everyone had a large deal of individual accountability and responsibility for doing their research on their own and completing pieces of their chapter on time, and then we would meet once a week and review each other's chapters, put it up on the screen, go through and review, pick it apart, edit, and really revise and better everyone's chapter.
Thanks. My name is Kristen Underwood. I'm a geologist and I'm also a present PhD student in the Department of Civil and Environmental Engineering. And I'm also funded in part by Vermont EPSCoR, in full actually, by Vermont EPSCoR Research on Adaptation to Climate Change program. And I authored the water chapter. I'll pass this along before I forget. So this chapter discusses some of the likely and potential impacts to our natural and our built systems from climate-induced changes in the water balance. Also presented our opportunities to build greater resilience in the face of climate change. Vermonters have enjoyed relatively clean and abundant water over the years, more than 24,000 miles of rivers and streams, and over 800 lakes and ponds provide drinking water and recreational opportunities, including swimming, kayaking, and fishing. And more than 290,000 acres of wetlands provide important wildlife habitat and act as sponges to attenuate floodwaters and recharge our groundwater reserves. However, in the face of climate change, changing rainfall, runoff, and temperature patterns will affect the availability and the reliability of our water resources in complex ways. And as average annual rainfall has increased in recent decades, likewise average annual flows in our Vermont rivers have increased. Based on climate model projections for increased precipitation, we can expect average annual stream flows will continue to increase over the coming decades. High flows are larger in magnitude and are occurring more frequently. For example, this graph presented here shows the number of high flow events on the Mad River in Moortown, Vermont. And that gauge is kind of unique in that it does have a very long-term gauge record dating back to about 1927. From the trend line, we can see that over those 85 years of record, this watershed has seen on average 10 more days per year of high flow conditions. It's an increase from 30 to 40 days per year to something more like 40 to 50 days per year. And by the end of the century, up to an 80% increase in the probability of high flows is projected under assumptions of high greenhouse gas emissions. So these changes will lead to more inundation and erosion flooding, having implications for both our natural and our built systems. We can expect more damage to our roads and to communities that are established along the riverbanks and shorelines, such as we experienced in Tropical Storm Irene. And under current land use practices, we can expect more crop losses from inundation and erosion flooding on our agricultural lands. And resulting from that increased flooding, we can also expect to see increased turbidity, likelihood for algal blooms in Lake Champlain and other receiving waters. So these are really significant changes or challenges for our communities, but I do believe that Vermonters are up for the challenge. After Irene, for example, with leadership from ANR and VTrans, we built back our road systems in ways that were a little more resilient to future floods where that was possible. In my hometown of Bristol, we have permanently conserved over 300 acres of riverside lands and forested floodplains along the Nehaven River upstream of the village, and in this way we will avoid future flood losses and attenuate flood flows and be better prepared for a changing climate. Significant technical and financial resources are available from both federal and state agencies to help local municipalities implement some of these adaptive strategies. So with that, I'll turn to Anne.
Okay, actually,
Oh,
it's
coming back to you for
Gillian.
forest.
I'm filling in for our forestry gurus, Sarah Ford and Sarah Piers. Both of them are teaching at this time, so they can't be here. They worked extensively on the forestry chapter, which really looked at the impacts of climate change on forests. And what they found is that no one has really done a comprehensive survey of climate change impacts on northern forests. So that was really their interest. There have been some studies modeling shifts in species ranges. This is one of the examples. And in general, most of these models are looking at higher temperature and longer growing seasons and their impacts on species. So for example, we might see more oak, hickory, and red maple, and perhaps decreases in more cold-loving species such as spruce and fir. Wet winters and warm, dry summers may favor both native and non-native pathogens and pests, including the hemlock woolly diligent, which is photographed here. We also expect that there would be more weather-related disturbances as we have high-energy storms. So not just increases in extreme weather, but increases in frequency of extreme weather. So this would include things like windstorms that can damage the forest, ice storms that can also damage the forest. So forests and their health can help provide resistance and resilience to climate change. So on a global scale, our forests are important for carbon sequestration and storage. If we look at the balance between greenhouse gas emissions and carbon storage, we, of all the states in the country, come fairly close to neutral. We emit slightly more than we sequester, and a large part of this sequestration is provided by our forests. We need to pay particular attention to threatened forest types, as I mentioned, such as spruce and fir, to think about how advances in forest management could help these forests thrive throughout climate change.
My name is Anne, and I'm actually, oops, I just skipped that. Anyway, I work for Suncommon, a solar energy company here in Vermont. But I was a student here at the Gund for the last 2 years and finished my master's in public administration in May, and was also involved in the same program as Kristen, the Research on Adaptation to Climate Change program. And the area of the Vermont Climate Assessment that I focused on has to do with how we are responding to some of the changes that we see as a direct result of climate change. And so looking at that, we look at varying levels of response on different governing levels. And so we have a chapter that focuses on climate change policy, looking at what are the responses coming from a state level, and then a chapter on community development. So then looking more at the bottom up work happening at local jurisdiction, or how communities are coming together to organize around building resilience towards climate change. And so these two different responses, the top-down state-level policy and the bottom-up community building, really focus on, we looked at how are we focusing on adapting to make adjustments to our way of life, how are we mitigating to look at how we're moderating some of our behaviors to lessen the impacts of climate change, and overall how to become more resilient to these effects of increased, a lot having to do in Vermont with increases in precipitation and flooding in communities. So this slide here just depicts the federal aid support received by towns for damages incurred by Tropical Storm Irene in 2011, and you can see the darker red areas, which indicate the higher value of funds that were received. But the entire state was actually, every single county in 2011 had a FEMA disaster declaration due to other intense smaller storm events that happened earlier on in the year. So the impact is really widespread, and that's sort of the story that it's telling. Some of the things that we really looked at in the Vermont Climate Assessment, looking from how there are these feedback loops between the community level and the state level policy, and there's the work that's going on at the community level is really driving some of the work that's happening at the state level, and vice versa. So some of the state policies are looking at a broad picture of how to implement new types of town planning and river management assessments, whereas at the community level, groups are coming together not only from the legal side, but volunteer and nonprofits, watershed-based organizations, Friends of the Winooski or Friends of the Mad River Valley. And so we're really starting to see a shift in our response from a more individualized town level to building communities together, and really starting to recognize the importance of basing some of the decisions on watershed boundaries, or looking at ecological boundaries instead of town lines. So those chapters go into much more detail as to what are some of the state policies that have been implemented, and then how that's impacting more on the ground community development.
Hello, I am Julie Nash. I sit upstairs here at the Gund, and I'm a PhD student, defending in a couple of weeks actually. And I worked on the agriculture section of the Vermont Climate Change. So I think that one of the things that is downplayed a lot of times in terms of climate communication is actually the opportunity that it can provide. And so that's one of the things that we looked at in terms of weighing the opportunities and the risks in terms of climate change, specifically for enterprises in agriculture here in Vermont. And I think that this is a pretty telling graph when you look at it. This actually shows across Vermont many different stations, and it actually looks at the Vermont growing season from 1963 up till about the present. And you can definitely see the visual graphic trends in terms of the longer growing season. And this is expected to be able to continue based on a lot of the work that was done by Gillian and the National Weather Service. So the frost-free period could increase by as much as 1 month by the end of the century. So as you can imagine, this does represent an opportunity for a lot of enterprises in agriculture in Vermont. It's not only a increase of crop productivity that could result, but also new and different crops that come in, such as grapes and a favorite of ours, peaches, to be able to bring into the state. And that's one of the stories that a lot of times isn't really discussed in terms of climate change. But to start off with opportunity, you also have to be able to look at the risks. And there are a lot of risks that come with climate change, some that have been touched upon. So one of them is the higher incidence of extreme weather events. So I think that we're all used to seeing some of the images of Irene that have happened in terms of infrastructure, but there are also a lot of images that actually show what happens in terms of agricultural fields being flooded. And that flooding doesn't just destroy the crops that are sometimes on the ground, but they also destroy longer term elements in terms of soil and other elements. In addition, there's an increase in terms of variations of actual temperature and precipitation. And I think that as we look at the Allen Home Farms data and what you discussed earlier, Gillian, in terms of how that can really affect an operation on the ground in terms of having those highs and lows in terms of temperature and what it actually does in terms of seasonal precipitation. Also, as part of this, is that there's a possibility, especially during summertime, that we'd actually have more short-term dry spells. And if you think about that in terms of agriculture and what that can mean, we don't have a lot of irrigation infrastructure currently within the state. So as we look at opportunities and risks, there seems to be a story to be told in terms of ways that we're able to potentially adapt. In addition, we looked at livestock, because livestock is an important aspect of our state, being a dairy and cheese state. And there is some indications that we would have more short-term heat stress on animals, which definitely reduces productivity. Now, don't get me wrong, this is nothing compared to other areas in the United States, which are going to have far more extreme heat and far more livestock loss of productivity from that. But one of the things that is important to realize is that a lot of livestock manufacturers depend on inputs that are brought in from out of state. And as we look at national trends, we can actually see potentially a lot of their input costs going up. So I have to admit that I looked at this from a business perspective, but I think that it's important to look at it from an opportunity and risk for these small enterprises and what this could actually mean for Vermont. So pass it on.
Thank you. Hi, my name is Elena Thompson. I'm a senior environmental studies student in the Rubenstein School. I clicked. There we go. Oh. And I'm interning for Gillian in the Vermont Climate Assessment this semester, supplementing the research and writing that was done by Danny on climate change's effects on public health in Vermont. So human health has the tendency to be overlooked a little when we're discussing climate change. But the changes in temperature, precipitation, and ecology that you've seen so far in this presentation are going to have effects on the health of Vermonters in a variety of ways. So one of these ways is extreme weather events such as flooding. They're becoming more frequent and severe. They can potentially cause injury. With increasing local temperatures, food and waterborne illnesses are on the rise. This can include salmonella, E. coli, and then toxic blue-green algae blooms. Vector-borne diseases are particularly susceptible to temperature and precipitation pattern changes due to the vector's complex ecological relationships. This includes the fast-growing rates of Lyme disease. In the top right corner, there's the incidence of Lyme disease from 2010 that is spread by the black-legged tick, as well as mosquito-borne diseases such as West Nile virus. These diseases ranges are moving farther north each year, and the vectors have longer breeding seasons due to warming winters. Another health effect of climate change is the aggravation of asthma and allergies due to more pollen and mold spores in the air. This is especially problematic for children and adults with pre-existing health conditions. There can also be changes in UV radiation as well as mental health, but these areas have been less studied in terms of scientific studies. So this is an example of the type of research that I'm doing with Gillian this semester as part of the health. These are two graphs that show the relationship between heat stress emergency room visits and days where the minimum temperature was 70 degrees or warmer, or days when the maximum temperature was 80 degrees or warmer. So there's a pretty clear correlation there. What's especially interesting about this study is that it's not one-day spikes in extreme temperature that cause more heat stress emergency room visits. It's actually the long periods of relatively warm days that cause heat stress problems. So this research can focus state public health prevention of heat stress into a more specific direction. So next. There is great new research coming out of the Vermont Department of Health, University of Vermont, and other organizations that are studying these effects for prevention and preparedness purposes. And the more we know about these effects, the more resilient we can be against them. There's a lot of research on extreme weather events, on vector-borne diseases, and asthma in the state, but an area that has received less scientific focus is the whole mental health aspect of climate change. In the years of the aftermath of Hurricane Katrina, there were numerous studies showing the increase in stress-related disorders such as PTSD, and similar findings were found in Vermont after Tropical Storm Irene. But there hasn't been as much scientific information placed on the underlying stress that Vermonters could experience and maybe already are experiencing related to the changing local environment. For example, maple sugaring is as much a part of the identity of Vermont as it is a source of income. So Vermonters are known for their strong connection to the land and the unique, vibrant seasons weave together the natural and cultural fabric of Vermont's diverse identities. How are we going to be affected by the changes in landscapes around us and our relationships to them?
I think I'm going to pop up because I'm kind of seated in a funny area. Hi everyone, I'm Elizabeth Palchuk. I'm a doctoral student in the Rubenstein School, and I also sit upstairs right across from Julie. I worked on, as part of this project, the energy chapter. And I put in a couple of graphs here that highlight what we're going to see. The first one is, and kind of the big message here is that we're going to see increased power outages due to extreme weather events. And for us, that means largely hurricanes and flooding events. And then lightning strikes. We're seeing a trend, an increase in lightning strikes. And we got this information from the National Weather Service. And so for utilities, that means planning for power outages and getting more people on these problems rapidly when they occur. What was interesting for me is that this information isn't necessarily new. Vermont's pretty on it when it comes to energy, and part of it's because of our goal of 90% renewable by 2050. So a lot of people have been working on this problem. The new data was maybe not going to be as useful as some other things that I could uncover. And so I put in a call, as I started to learn this, I put in a call to Asa Hopkins, who is the Director of Public Service here in Vermont, and he's really the person who is in charge of achieving this 90% renewable by 2050. And I said, you know, there's all this data out there, but it seems like this is probably stuff that you know and stuff that you're working on. What can I contribute? And he said, the big question for me is not necessarily adaptability and resiliency and mitigation. It's really how can we use what we understand about behavioral scientists to change how people are using energy. And so that's what a lot of the energy chapter focuses on. So there's a lot of information in there about how energy systems will be disrupted by climate change. We're going to see higher use of air conditioning in the summer that will outweigh the fact that we will see higher temperatures in the winter, and so use less heating. But those are things that we kind of already knew. So I went into the behavioral sciences world and tried to understand why people use energy, how they use it, when they use it, who uses it differently, and with the hope that it would be useful. And an hour ago I presented at the Renewable Energy Conference to a bunch of practitioners, the folks that are trying to apply this information, and there was a lot of interest in the room, I think, on trying to use some of this work from the world of the social sciences to figure out some of these complex problems.
So Sam isn't here today, so I'm just going to briefly go over some of the key messages from his chapter, which was on recreation and the tourism industry in Vermont. So a big takeaway from the chapter that the media really focused on a lot was this sweet spot in Vermont between 2015 and 2040, where precipitation will increase, but temperatures won't increase past the point where we don't get a lot of snow. But then past 2040, more rain, higher temperatures, and recreation opportunities will decline. I think in his report, he found a lot of estimates that basically said the economic opportunities for ski resorts in Vermont will actually be increasing in this sweet spot, both because of the increased snow and because ski resorts further south will start to lose business. And that through 2075, about 18 of the ski resorts in Vermont should remain economically viable, according to current projections. In the summer, you found longer summers mean improved recreation and tourism. It's easy to figure out. And that in the spring, there will be a much larger and more intense mud season. Also pretty easy to figure out.
So what's next? First, I would encourage all of you guys to stay in touch with us. As I mentioned at the beginning, our report is online. We're active on Facebook and Twitter, so you can follow us there. Occasionally we post things on Pinterest, but kind of cool. But going forward, there's the big question about what does the Vermont Climate Assessment become, or how does it evolve over time? So what is our future mandate? And I would say that that comes from you, whether you are faculty or a student or a community partner, someone out there. The more that there's a demand for this information or for being part of this process or for learning, the more we will be able to do. Okay, so it's not just me leading a class, but we need to become a community of scholars here at UVM who help answer these questions in a very rigorous scientific way that can be shared and enacted on in terms of policy and management and future planning for resilience in Vermont. We have a great community of stakeholders, but I think there's always more out there. I showed you a few examples of our citizen science. I would love to be connected with more people who have that kind of data. There's got to be folks doing maple sugar who keep records of when sap starts flowing and when it stops every year. So let's keep trying to gather those records. I think there's also got to be a commitment in the academic community to learning, teaching, and communicating about climate change and its impacts. So that comes both from student demand and from teachers. And in terms of stakeholders, we have a lot of K-12 educators who are looking for help teaching climate change throughout the state as it's now part of our science standards. And we have some real opportunities to be networked with local schools to teach local information about climate impacts that students can really relate to. And finally, just like the National Climate Assessment, I think the Vermont Climate Assessment needs to be some sort of ongoing effort. For example, we have Elena working this semester to further our work in health. I could foresee a future where we have a coordinated set of senior honors theses working on related topics, but led by individual students. Obviously, it works well at the graduate level, but I think there's also opportunities to take it into the undergraduate level. We have a long list of acknowledgements, so I will leave those up there while we open for discussion. Thank you.
Thank you, this is great. I'm interested in like what you've done with this in terms of outreach and engagement. You know, you said you talked to a lot of non-academic audiences. In terms of thinking about climate literacy and also then and then a follow-up question is how do when people hear this, I mean, then because oftentimes people say, okay, so what can I do? I mean, I don't know if that's the message, but I can imagine sometimes that is. And I'm involved in a project that's looking at climate literacy and energy literacy, and they're actually like two separate efforts. So it's obviously nice to see that you guys are trying to integrate some of that. But like there's a national climate literacy document and a national energy literacy document, and the climate hardly mentions energy, and the energy literacy hardly mentions climate change. So I'm interested in that connection too. So I don't know anything in that.
Sure, I'll start with the outreach question.
Yeah.
So we had a large stakeholders rollout event in June with about 250 people who attended. We had expected 100 or less. So a huge success, a number of media outlets. We were featured on all the local news stations. We were picked up by a regional public broadcasting station based in New York. We've been featured on Vermont Edition, on Vermont Public Radio. Next week, at the invitation of the Regional Planning Commission of Rutland, I will be presenting on a few targeted topics that their commission is interested in. In November, we'll be part of a legislative summit day here at UVM focused on climate change, so we'll be presenting the results there. And we have some discussions about working and presenting some of this information with the State Climate Caucus, so our legislative representatives there. We were picked up by Reuters and the AP, so we were featured on a huge number of sites. Our website itself has gotten almost 9,000 hits since June, so a lot of traffic. I'm going into some high schools coming up soon. I think that kind of covers like the range of outreach. It's certainly been very well received, and I think that's because of good communication on our end, trying to really make it relatable. Huffington Post, yeah, they picked it up. And your second question, thinking about climate literacy, is that what you're?
Yeah, well, I guess I was also like, what do you offer people if people say, what can I do about it? I mean, I guess it's different for every audience, right? Like, what can you do? And some audiences are as you mentioned, are, you know, this is good for Vermont, right? In some ways. So maybe we don't need to do anything, you know.
Right.
I'm just curious about
Yeah,
that.
no, so each chapter probably has a different focus of recommendations. And one thing is that the word resilience is already part of Vermont's vocabulary, in part because each town, as Anne wrote a lot about in the community chapter, each town is mandated to have a resilience plan primarily focused on flooding. So this idea of resilience is really well received by Vermonters and is a very powerful word. So we're not adapting, we're not mitigating, we're building resilience so that we can thrive in the face of change. And that was really our theme throughout the chapter. So not to just gloss over negatives, but to also think about if we know that there are some potentially negative changes, how can we prepare and thrive in the face of them? So for each chapter that plays out in slightly different ways. Agriculture is a great example. We're thinking about opportunities and also sort of minimizing your risks. So as a farmer, you might be looking to build a little bit more savings to buffer yourself through times of extreme flooding or drought. You might be looking for small grants to buy a longhouse to extend your growing season.
So for each one of the chapters, I know for the agriculture chapter, for instance, it did have more of a focus than what we talked about here in terms of mitigation and then adaptation. So different mechanisms that an individual farmer would be able to use to extend their growing season and to be able to, to be able to offset some of the potential risks that they would have. But then also looking at what type of agricultural produce you're producing, because there's new opportunities that come. So it was a little bit more tailored in terms of that, at least for the agriculture section. I don't know if anyone else wants to talk about how they had specific recommendations.
Sure, I think in the water chapter, for example, I did try to include examples of mitigative or adaptation strategies that could be implemented by various sectors, so the ag sector, municipal sector, landowners, individuals, forest sector, so.
But it would be a great opportunity to think about like a climate change communications course that could work on delivering, you know, flashy one-pagers to give out, or posters to have in high school classrooms, or more materials like that. So it's not just listen to what we said in these presentations or go read a chapter, but something that you know, could target certain audiences. So that, I mean, there's so many possibilities of how to make interpretive.
Could I add on to that? One of the things I think that Gillian did a fantastic job in, so sorry, you probably won't say it, is there's a reason that there was such incredible media coverage, I think, and it's because of how the communication was framed to the local community. There were a lot of fantastic sound bites and stories, ways to be able to make climate change become very real and for people to connect to it on a local level that I think was really well packaged in the original chapter and then in the presentation. So we had a lot of people come to the event, but I think it had to do with the way that the communication was framed in terms of the amount of coverage that actually came and continues to come with stories like Joe's Pond's ice out. I mean, that whenever I tell that story to someone, they always kind of stop and, what is that? Let me, you know, because I mean, it's such a local kind of folklore story. So I think that that's an important part of the communications.
Julie, you mentioned mitigation. And I remember the first time I heard this statement, I sort of, when the statement was, adaptation is not surrender. Adaptation is not surrender. My specific question is, when you talk about mitigation with folks, what are you doing? You're trying to present a future that looks so undesirable that they might do something about energy or about carbon? Or is there not that much interaction between mitigation people and you people?
Certain aspects of each chapter focus on mitigation, some more than others. So agriculture and energy are two sectors that are very important in Vermont and definitely are part of our contributions to global climate change. So I don't know if you guys want to say anything about how you,
Yeah, I mean, in the climate change policy chapter that focuses on the policy specific to the state of Vermont around climate change, there's a section that talks about some of the mitigation strategies, looking at, you know, Vermont being a part of the Regional Greenhouse Gas Emissions Initiative, or, you know, looking at some of the efforts to increase, you know, renewable energy sources in the state, whether that be through transportation, infrastructure, you know, or more on a household level. So, you know, we focus on mitigation in that sense, but like Gillian was saying, I think a general theme throughout the full assessment is to not just think about these pieces individual of each other, as mitigation is one thing, adaptation is another thing, resilience is another thing, but really, you know, what does it look like, the overall picture, and what we're doing specific to Vermont to build these different pieces into becoming a much more resilient picture in the end.
And as an interesting side note, there's been a couple of new research reports that have come out of Europe looking at the economic impacts of mitigation policies, such as green development of green infrastructure, so renewable energy sources, public transportation, things like that, and actually tend to spur economic growth. So you have a more desirable neighborhood if you're living in a place with cleaner air and a better infrastructure system for public transport and things like that. So some of our mitigating activities may actually provide an economic benefit, not be an economic cost in the long run.
Julia, about the agricultural conclusions, are those conclusions based upon the trend lines, or are they based upon the variations within? Because you know, agriculture is inherently risky.
Right.
And so therefore, I mean, especially, I mean, I know I have peach trees in Vermont, and I have them in a microclimate, etc. But you know, it is even though relatively the same climate as Ontario, which is famous for peaches, because the variations are so slightly different. It's, despite all my best efforts, there are just too many factors of uncertainty that there hasn't been the traditional knowledge built up that is so inherent in agricultural systems. So basing, you know, business decisions on trend lines versus variation, is that something that you looked into?
Well, we definitely based the recommendations on both. So, for instance, if you look at something like hoop houses, which has the tendency to potentially insulate farms from the fluctuation in temperatures that happen right at the spring or the fall, to be able to have a better extension of growing season, that reduces a potential risk. We did not go as far as suggesting specific crops that can, but based on the trend lines and based on actually economic activity that's happening here, you see the winery growth that's happening within the region, which can be a direct result. So in terms of the specificity, each individual business owner or person who's looking at their crops would need to be able to assess the risks and the opportunities. So much is based on their small microclimate anyways. But knowing that there's going to be an extended growing season, or knowing that there might be opportunities to be able to diversify your crops, is something that's a universal message, I would say. Does that answer your question?
Yeah, I mean, I wasn't sure how far you were going in the opportunities of, you know, doing the
I know that there are people who are in extension, agricultural extension, who are doing more work in this area. So I think that there's an opportunity for future collaboration in that area.
That's all the time we have today. Thank you very much.